All right, Mavericks, here it is, my first YouTube video for the pre-calculus class. The topic that we're going to look at today is solving trigonometric equations. The problems that we're looking at are actually coming from a text called College Trigonometry, and I've actually given you in the review packet for next Tuesday's makeup exam a handout with some problems. And the first one that we're going to look at is the solution to problem number 16. Okay. The problem reads 2 sine squared of x minus 1 is equal to 0. Since this is an equation that doesn't have a middle term, it's quadratic and it only has 2 terms, my opening move is I'm going to actually separate it, and I'm going to move the negative 1 to the other side to make it 2 sine squared of x equals 1. After that, I'm going to divide both sides by 2, so we get down to sine squared of x equals a half. Now here's the part where some people are still having some problems. Once you know that sine squared of x equals a half, we're going to take the square root on both sides. So this is where it looks a little bit longer. Sine of x is going to be plus or minus the square root of a half. If I use my properties of radicals, I can rewrite this as plus or minus the square root of 1 over the square root of 2. Square root of 1 is 1, so we get plus or minus square root of 1 over the square root of 2. We're going to rationalize the denominator, and ultimately we're going to get plus or minus the square root of 2 over 2. So that means we're going to have to look to determine where is the sine of x equal to the square root of 2 over 2, and where is the sine of x equal to negative square root of 2 over 2. For both of these, I'm going to draw the appropriate unit circle. If the sine of x equals the square root of 2 over 2, that's going to happen in 2 places. It's going to happen in the first quadrant. If I want the sine to be the square root of 2 over 2, that means that this side here has length square root of 2 over 2. The angle across from that is going to have to be 45 degrees. In terms of radians, that's going to give us pi over 4. But the sine of x is also equal to the square root of 2 over 2 over here in the second quadrant. Now that central angle is still going to be 45 degrees or pi over 4, but the way that we measure our angle, we're going to measure it from the 0 all the way over. That's going to give us 135 degrees or 3 pi over 4. Because I didn't mention a restricted domain in this problem, we're going to look for all solutions, so that's going to get us pi over 4 plus 2 pi k and 3 pi over 4 plus 2 pi k. For the second part of the solution, we're going to look at sine of x equals negative the square root of 2 over 2. Well, if the sign is going to be negative, we're going to look in quadrants 3 and 4. So I've drawn the appropriate triangles. If the angle is if we're talking about the angle in the fourth quadrant, I'm going to write that as negative pi over 4 plus 2 pi k. For the angle in the third quadrant, it'll be negative 3 pi over 4 plus 2 pi k. And that completes the solution to problem number 16.